This is a brand new unit that we're going to work on. Now, I'm making this video outside on a Wednesday. My dogs are here, the neighbor's cutting his lawn, and it's windy, so if you hear some weird sounds, try to bear with me on this. But this new topic we're going to be working on is a study in trigonometry, and the most basic trigonometry is the stuff we're going to learn this year, just so you're ready for next year in geometry class when the teacher starts to talk about sine, cosine, and tangent, sometimes represented, or actually always represented, with sin, cos, and tan. So sine, cosine, and tangent. And what sine, cosine, and tangent are used for is, at this point, to help us find side lengths in right triangles. Now, we're going to do more than just that with sine, cosine, and tangent, but that's what we're going to begin with. Now, to do this, we have to understand a few different things about right triangles. First and foremost, we have to know what sides are which. So this first bullet point here says, when looking at angle theta, theta is the line with the circle with the line from left to right, which side is the hypotenuse? Now, a hypotenuse, you probably already remember, is just your side that is opposite of your right triangle. So this is always going to be your hypotenuse right there. Let's move this pencil out of the way. There we go. Sides that are adjacent sides touch the angle that you're dealing with. So if I'm going to go ahead and take the adjacent side and copy and paste it, I'm going to take my adjacent side and I'm going to put it right here. The adjacent side always touches the angle itself. And then the opposite shouldn't be too surprising for you. The opposite side is going to be the one that remains behind. So we're going to go ahead and paste that here. And that side is the opposite. So keep that in mind. Now, if theta changes location, the hypotenuse doesn't change, but the adjacent and the opposite sides would. This is a good time to stop and pause. You try this one on your own. Pause the video and then push play when you're ready. All right, here we go. How long is the hypotenuse? The hypotenuse is always the side that's across from the 90-degree angle, so it's 8 no matter where theta is. Theta is opposite of side 4, so opposite is 4, and adjacent would be 6.9, so 6.9. Hopefully you have that same thing. Let's move on. Now, when I was in high school, I had a really bad student teacher who taught me this mnemonic device. It's the only thing he taught us in 16 weeks, but he taught us SOH-cah-toa, SOH-cah-toa. And this mnemonic device is a way in which to remember the sine, the cosine, and the tangent functions. Here comes those words: opposite and hypotenuse, adjacent and hypotenuse, and opposite and adjacent. And what we're finding is, if we can take the sine, the cosine, and the tangent, we're going to use a calculator for this, by the way, and input a particular angle, we'll end up getting a ratio on the other side. The ratio can be represented as a decimal, or it can be represented as a fraction. We're going to work on that as we go. All right, here's an example in blue of one that I did already. I have angle theta right here, and the first one's sine of theta. So sine is so opposite and hypotenuse, opposite and hypotenuse. So you see the sine of theta is just 5/13. By the way, Get More Math will type it as 5:13. I don't know why they do that, but that's just another way to represent a ratio. The cosine is CAH, C-A-H, so adjacent and hypotenuse. There's your 12/13, or again 12/13. And for tangent, you could probably guess what tangent is going to be. You can see it written down here. Tangent of theta is going to be opposite over adjacent, so 5/12. The purple shows that the size won't make any difference. These 5/12 and 12/13 and 5/13, they're all the same for the purple as well, because the size of the triangle doesn't make any difference. Now, let me have you pause again and see if you can try this next question. Find the tangent of angle B. All right, if you're back, tangent is TOA. So we have tangent of angle B is going to be O, the opposite, over A is adjacent. So opposite of angle B is 4√3. And adjacent is going to be, well, one of the two sides that touch it, but not the hypotenuse, so 4. And this thing cancels out to be square root of 3, so boom, that's your correct answer. Let's move on. Now, the good stuff is, what do we do when we're finding missing sides? This is one of the main reasons why we get to this. So here's what we have, a right triangle with two angles known, 90 and 26. We know we could figure out the third angle if we need it, but we don't really need that one. And we have one side length that's 25, that's the hypotenuse, because it's across from the 90-degree angle. And we know that this side over here is, well, it's opposite of the angle that's given. So in my first bullet point, it says, what angles do you have? You have 26. What sides do you have in relation to the angle you have? Well, you have the opposite and you have the hypotenuse. So now I need to think about what trig function can you use. So I have SOH-cah-toa. And I want one with an O and an H. And the only one that's going to fit the bill is going to be SO. So we're going to use the sine function. So here we go. I'm going to write the sine of my angle is OH, opposite and hypotenuse. All right, now with sine of 26 equals 25 x over 25, this is just an equation. I'm just going to multiply both sides by my common denominator. My 25 is going to cancel out, and I'm going to get whatever 25 times the sine of 26 is. So 25 times the sine of 26, and I'm going to use a calculator for this. So 25 times the sine of 26, so 25 times the sine of 26 is 10.95. So 10.96, I guess depends on how Get More Math wants us to round it. I'm going to go ahead and say 10.95 or 10.96 rounds up to be approximately, approximately 11. So Get More Math seems to like things rounded to the nearest tenth, so this one I would have to round up to 11. Let's do one more, and then this video is all over. Plus my battery's about to die. Here we go, second example. What angles do you have? Well, let's see. Excuse me. I have a 70. I have adjacent. I have a hypotenuse. Let's see what we got. We have a 70 degrees. The sides that we have are the adjacent and the hypotenuse. What trig function can you use? You have SOH-cah-toa. And this is the one we're going to use because we have an A and an H. So here we go. Cosine of 70 degrees is AH. A is 10, H is M. Now, a couple things we could do here. We could use the same exact approach as last time, multiply by a common denominator. We would get M times the cosine of 70 equals 10. That's fine. And then I'm going to divide both sides by the cosine of 70. I haven't actually typed this into my calculator yet. I want to do that all at once. Cancel out my cosine of 70, and the M is, well, whatever 10 divided by the cosine of 70 is. So let's go to my calculator. 10 divided by the cosine of 70, and 29.2. So we're going to go ahead and say 29.2 is our correct answer, and really, that's all there is to it. So for the remainder of this video, here's what you have to work with. You should probably pause the video and try these 4 questions in the notes that you have. If you're just watching the video without the notes, then this is a good time to stop. If you're in my class and you have the notes in front of you, then there are 4 questions to try. You should pause, you should go ahead and try those 4, and then inside of the notes, scroll on down and check your answers. I'm not going to show the answers in the video because no one's going to do them from the video anyway. So watch these things, so here we go. Do these 4 problems, turn the video off, and then check in the document itself against the answers that are listed. All right, so good luck working with trig functions.